Hello! In this Unity tutorial, we're going to take a look at creating our own first-person controller. There are a handful of first-person controllers available for free and paid on the Unity Asset Store. I would encourage you to take a look at them as reference. One notable one is the Unity Standard Assets. In the Characters folder, they have both a first-person and a third-person character prefab that you can use and drag into your scene. On this channel, we'll be covering custom first-person and third-person characters, so I hope you're excited for that. Now, the reason why we are doing a custom implementation of the first-person controller is to more provide you with a solid foundation of the various components that are working together to create the first-person controller, rather than just downloading a pre-built one off the asset store. It really goes a long way to understand each of the components, how they're interacting with the script, so that we get a full picture of what is actually going on. And that's going to give you an upper hand in the future when you go to add on to this first-person controller. You'll know exactly where things are in your scripts, rather than having to dig around in a bigger first-person controller and code that you didn't write. Okay, so to get started, what I would like you to do is go ahead and create a blank 3D project. Now you can see here I already have one pre-built and pulled up for us, but do not worry, we will be walking through everything in this scene together. If you need help on creating a 3D project, please either visit the project setup video on this channel, or take a look at the Unity Terrain Basics video. In the first 5 to 10 minutes, it talks about how to set up a new 3D project, although the process is very similar for both 2D and 3D. Okay, so when you are in your blank 3D project, if you take a look at the hierarchy on the left side of your screen, you will notice that there are two objects in it if you selected 3D. The first one is going to be a directional light. The other one is going to be the main camera. You can see mine is set up a little bit differently. Don't worry too much. We're going to change that in just a moment. The directional light is just providing basic lighting for your scene. Go ahead and leave that enabled. Now the main camera is of course how the user is going to be able to see the world. It's going to be their perspective. Alright, to lay the foundation for our first person controller, if you take a look in the scene here, I have a capsule in the center of my scene. So what I would like you to do is, in the hierarchy, go ahead and right click, select 3D object, and from here select capsule. Now this capsule will likely spawn at a random location. Go ahead and move your cursor to the transform component in the inspector. Right click on the name of the object in the transform and go ahead and select reset. That's going to set these values back to their defaults, 0s for the position rotation and 1 for the scale. Let's briefly talk about what components come on this capsule. So if we bring these down here, we have two components that are strongly related. The first one is the mesh filter, the second is the mesh renderer. Both are critical for being able to display this capsule on the screen. Now you'll learn more about these if you take our computer game design course, where we get into a bit more information about the complexities of creating models and such. But as a high-level overview of what these things are, the mesh filter is responsible for storing the 3D data about this capsule. So the capsule at the end of the day is just an array of numbers inside of the computer. Essentially, it's an array of triangles, and each of the triangles has a position associated with it. We have 3 vertices for a triangle, meaning we have 3 different positions. So this is storing a giant array of triangles representing our capsule. Now the mesh renderer, we can actually turn on and off. If you look at this checkbox here, notice when I turn it on and off, let me go into my scene, and don't do this, I'm just going to move mine over so we can see it a little bit. If you tick this on and off, you'll notice that the capsule is enabling and disabling, coming into view. The reason why this is happening is because the mesh renderer is responsible for taking the data from the mesh filter and displaying it on the screen. We are not able to disable the mesh filter because that is inherent to the capsule object itself. This capsule object would not be a capsule if it did not have that 3D data associated with it, so that's always going to exist with the object. But we have the option of telling Unity, hey, do you want to display this, yes or no? That'll be the mesh renderer. Now all of the settings here are not relevant to this video. Take a look. More specifically, we talk about it in our prefabs video, as well as an overview of the textures, materials, and shaders. That will be covered in those videos on this channel. Okay, so that is the mesh filter and mesh renderer. Now let's talk about the capsule collider. So this, if you haven't seen the physics video on this channel, I would strongly recommend you to watch that after this video, although I'm going to give you a description of what it is here. In Unity, objects can interact with each other. To be able to interact, such as hitting each other, they have to have a collider on them. Like when you touch your arm, for example, if your hand obviously doesn't go through your other hand or arm, that's because we are pushing in on our skin, but it's also pushing back at the same time. Essentially, it has a collider on it. It prevents my hand from going through my other hand. And that's what we want to be able to mimic inside of Unity, essentially. So if you want an object to be able to not go through something, add a collider onto it. There are multiple types of colliders that we talk about in the physics video. This is a capsule, so a capsule collider makes sense for that. We also cover these properties in that video, but they are not relevant for this video. So we have the 3D data, we have a way to display the data, and we have a way to collide with things. If we take a look at my player here, go ahead and also, with the capsule that you created, a handy little trick is there's two ways to rename something. You can either press F2 on your keyboard and then you can rename it, or you can select on the object and in the inspector you can change the name in the upper right to whatever you would like to call that capsule. Alright, so looking back at my player, we covered these three things, and then there's two additional things that I'd like you to go ahead and add. The very first thing is going to be a C# script. So in your assets folder, please go ahead and right-click, create folder, and call this folder scripts. When you have created that folder scripts, go ahead and go inside of the folder. Here we're going to create two scripts. Let's start by creating the first one. This script is going to be called player movement, P and M uppercase, no space between that, so player movement. To create the script, right-click inside of this scripts folder, select create C# script. When you do that, it's going to prompt you for a name. That's where you're going to type player movement. The reason why I already have this done and set up is because it'll slow the video down immensely if I am talking and writing code at the same time. It'd be a lot faster for me just to be able to talk through the code. You can pause the video to catch up and then we can have a discussion about it. Okay, once you have created the player movement, go ahead and delete this out of here. Go ahead and go to your player object, your player capsule, add that script onto it. You can either click, hold, and drag this script directly from this folder onto the object, or you can select add component and search for player movement and it will pop up there. Alright, let's go ahead now. You can see the character controller component on here as well. If you want to go ahead and press add component and search for character controller, go ahead and add that now. We'll be talking about that as we open up the player movement script. Okay, so go ahead now in your scripts folder and double click on the player movement to launch that script. This script looks a little bit long, but I promise it won't be too bad. We're going to take this one at a time. You can either go ahead and write it all out if you would like, but I'm going to go chunk by chunk, and I would encourage you to type it out after we've had a chance to talk about it, to reflect upon it. So I'm going to hold Control and scroll with my mouse wheel to zoom in just so I can give you a up-close view. If you haven't had a chance to check out the Introduction to Programming Part 1 and 2 on this channel, please take a look at that as it covers some essential topics that we'll be talking about shortly, such as variables and methods. Alright, so we created this class called Player Movement, and for you, it's just going to contain the start and update function. We want to leave those functions in there. For the time being, go ahead and go above your start function, but below the opening bracket for the class. And let's talk through this first chunk here. So here we have what is called a header. So the header says basic movement properties, and this is more of a stylistic choice as it's going to make these variables very noticeable on the inspector. So after you have typed in these 5 lines, go ahead and save your script. When you go back to Unity, it will recompile and refresh your inspector. If you select on the player, you'll notice the basic movement properties header, and you'll have the walk, run speed, gravity, and jump height that are all defaulted to a value of 0. Go ahead and enter these values: 2, 4, negative 9.81 for gravity, and a jump height of 3. Of course, you can set these to whatever you would like. These are just the values that I'm using for this tutorial. Okay, so going back to our script now, these are public variables which are going to allow us to set their values from the inspector. Whenever we want to update these values, we can't set them from inside the script now. It's best practice to set them from the inspector. The next section of code here is also a header for the ground check properties. So go ahead and type these 4 lines of code out now. So what these lines of code are doing is it puts a header onto the inspector that we can see here for ground check properties. And there are 3 different variable types that I would like to talk about. So the very first one is the public transform ground check. You'll notice in this case that the transform is uppercase. That is referring to the transform class. Because it's public, it's going to show up on the inspector, and it's going to allow us to drag a game object inside of it, and it's going to directly reference the transform properties of that object. So let's go ahead and go back to Unity with this in mind. What I would like you to do is you have your capsule called player. Go ahead and create an empty game object, and make sure that this game object is set as a child to this. To set it as a child, click, hold, and drag on the object in the hierarchy directly on top of the player capsule name. That will move it so that it's underneath the player game object. If you bring up the drop down, you should notice it disappear. That will let you know that you have done it correctly. If it doesn't disappear, then it's not a child of that game object. We'll go ahead and rename this to ground check. So you can see I already have one here, so go ahead and press F2 and call this ground check, just like that. I'm going to go ahead and delete mine since I already have one. Now, with the ground check selected, go ahead and set the Y value to -1. Now, the reason why we're setting the Y value to -1, if you take a look at the capsule here, the capsule has a specific height with it. So, if we take a look at the character controller here, it has a height of 2. It's positioned at Y is 1. Y is 1 is going to be the center of this capsule. So if we go to -1, that is going to be the bottom of this capsule. So just double check by clicking on it in the hierarchy that this empty game object is set to be at the very bottom of this capsule. The reason why we created it is because when the character jumps, we need to be able to tell when the character is in the air versus when they're on the ground. Okay, so with that set up now, let's go ahead and go back to the script. So again, this is storing the positional information about that ground check object used for jumping that we just created. The next one is the ground distance. So let's go ahead and go back to Unity, and we'll select on the player. Now if we take a look at the ground distance here, this is going to be used to determine how close this ground check transform is to the ground. So it's going to give us essentially a small ray that's going to shoot out from this empty game object. And if it hits the ground within the zero point 0.4 units, 0.4 meters, you can say, then it will say, okay, we are on the ground. But if it doesn't, it says we are in the air. I apologize if that explanation is confusing. It will make more sense when we look at the actual jumping code. For the time being, just know that this variable ground distance is going to be used with respect to jumping to determine whether or not we are in the air. The next thing is a layer mask. So a layer mask is a little bit more of a complex topic, but a layer mask is essentially this. Objects that we want to be able to jump on, we need to add them to this layer mask. So go ahead and create a plane game object. So you can see that my player is resting on a plane. To do so, go ahead and right click in here, 3D object, then select plane. When you select plane, that will create a plane at a randomized position. Again, just like we did with the capsule, we'll go ahead and right click on it and select reset. That'll position it back at 0, 0, 0. And then what you're going to want to do is I encourage you to go ahead and rename it to ground so we know that that's what the character is going to walk on. We're going to have to create a new layer. So with the plane that you just created selected in the hierarchy, view the properties of it in the inspector on the right. In the layer dropdown, you can see I have a layer 8 called ground. You don't have this yet. Go ahead and select add layer. In the layer number 8, go ahead and type the word ground just like this. Then to be able to set it, once you have this typed in, go ahead and select back on the object in the hierarchy, and then you will be able to go to layer and select ground. So the ground again is going to be what the character can actually jump on. This is really helpful, for example, if you have different types of terrain and certain types of terrain you don't want your character to be able to jump on, we would be able to control that via these layers. In the physics video, we talk more specifically about layers. Okay, so these are probably the most complex things that we're going to talk about with respect to variables, but so far we have these two sets of variables in there. Let's go ahead and add the final set here. So these are going to be private variables. So the difference between public and private again is private variables are not going to show up on the inspector. So if you haven't added the character controller yet, go ahead and do that now on your player. Leave the default values as they are. This character controller reference here is going to be used to reference all of the properties on this character controller. Next, we have a private Boolean value. A Boolean represents a true or false value, and this is called isGrounded. It's going to tell us whether or not the character is on the ground. And finally, we have a vector 3. So if you don't know what a vector is, you can almost think of it as an array of 3 points where we have x, y, and z that we're storing in it, and it's going to be representative of the vertical velocity for the variable name. Alright, so there's nothing we need to set just at the moment here. Just go ahead and type those 3 variable declarations in. Alright, so now we have made it to your start and update function that are empty by default when you created this script. Starting with the start function here, again, that start function is going to be called after the awake function. We talk about the awake function in advanced Unity scripting on this channel. But the start function will be called as the Unity scene loads. It gets called automatically, so you don't need to worry about invoking it anywhere. In the start function, we are actually setting the reference to the controller game object. So we say controller equals get component character controller. So this is a complex statement if you haven't seen it before. We reference the character controller up here as a private variable, so it didn't show up on the inspector. In the start function, we're saying, okay, I would like you to go get the component of the character controller. But you may be asking, where is it getting that component from? Well, if you remember, we are inside the player movement script. The player movement script is attached to the player object here. the character controller is also attached to the player object here. Because they are on the same object, a handy little trick that we can do is go ahead and get the component off of the same object that we're on. If you remember, we can always add components onto game objects, and we are now introducing how to get components off of game objects. To be able to interact with the character controller at all, you need to remember to set this reference, and it's best to do it inside of Awake or Start. Alright, so now we're going to go ahead and move into the actual logic of the character controller, which is going to be in the update function. So in the update function, here you can see we have two method calls. So what we're going to have you do first is go ahead and create these two methods. So the first one we're going to create is a private void check horizontal movement. So private means no other script is going to be able to access it. Void means it's not going to return a value. And then this is our name. So specifically what we're doing inside of here is, I'll give you a moment to type that out. Okay, so for each of these lines here, starting at the beginning, we have a float, which is essentially a fine point precision decimal number representative of x, and we say that is equal to input.getAxis horizontal. We also have a z for vertical. So if we take a look at our project input settings, so let's actually go back to Unity real quick and go to Edit, Project Settings, Input Manager. If you take a look at this, this is where you can actually view your axes. So you can see we have a horizontal and a vertical axis. This is what that script is referring to. When it says input.getAxis horizontal vertical, it's coming here to the horizontal to the vertical, and you'll notice that in the negative and positive, it is getting the values of left, right, or A and D, and then vertical is getting down, up, and S and W. So essentially what this is going to enable our character to do is move when the user is typing WASD, which is a standard configuration for most PC games. Okay, so this is going to return values between two constants, I believe -1 and 1, and we want to be able to interpret those values. So next here we have the vector3 movement. So the vector3 again is going to be 3 points. This is going to represent how the character is moving. So what we're saying is we are going to take the transform.right, multiply it by x. Now what transform.right is, if you remember inside of Unity, let me go ahead and close the project settings window. Up here, this is a good reminder of what it is, or even this Cartesian plane here. We have the z-axis, which is the blue, we have the x-axis, which is the red, and then we have the y-axis, which is the green. The WASD is going to move the character forward, back, left, right. So you can already see that we need to interact with the Z, or the blue, and the X, which is the red. We're going to be getting values from those. The transform.right, which is this line here, what it is representing is the x-axis. So it'll have a value of 1, 0, 0, because it's doing it along the x-axis. And then we're multiplying that vector by the horizontal. So if I'm typing in A is going to make the character go left, which in that case it's going to be a -1. So what it's going to do is it's going to do transform.right, which is 1, 0, 0, multiply it by another vector, or sorry, a float in this case. So you're essentially multiplying that vector by a scalar. So you'll get -1, 0, 0 as the resultant, and that will allow it to move to the left. And then what we are doing here is we are doing vector addition. So this, if you have ever wondered why linear algebra, or even calculus to some extent, but more specifically linear algebra, why that class is so important, we deal with matrices in Unity. They are essentially our life. We are always doing some sort of matrix calculations, scaling them together, adding them together. So it's really important to have that solid foundation in place. But of course, I'm going to talk through all of the logic here. But first we apply a scalar to this vector, and then we go ahead and add them together. Now the transform dot forward is going to be the 0, 0, 1, because remember we have x, y, z, so z is going to be that forward direction. So in this case, it's going to be 0, 0, 1 multiplied if we are pressing W by a positive 1, if we're pressing S by a negative 1. When you combine these two vectors together, so the transform dot right, transform dot forward, you get a 90-degree angle, and if you, of course, apply a negative to that, that's going to be the inverse of it, so it's going to cover all directions of movement for that, which is what this line is representing. Alright, so the next four lines here are just a little bit of logic that if the player is pressing the left shift, so if input.getKey, keycode.left shift, take the controller and move it. So this is referencing the character controller that we initially set up in the start function. We're saying controller.move. So controller.move is just going to take more or less the movement vector that you want to move upon, which is why we calculated it previously in the video. So we have the movement, which is at this moment just going to be a vector of either -1 or 1 on x or z. We're going to multiply that by either the run speed or the walk speed. So this can be a value other than 1. However big this is essentially however fast that character is going to move. And then finally we're multiplying it by time.delta time. So whenever you're doing any sorts of physics movements, you want to be sure to multiply by time.delta time. It's going to assure that the character is going to move X amount of meters in X seconds at a constant rate. If you don't multiply by time.delta time, your physics calculations are going to be subject to the frame rate, which is going to be subject to however good your computer performance is per se. You're not going to get a consistent motion across the screen. It may judder across the screen. The time.delta time multiplying that does it independent of the frame rate and will assure that the character will always move X amount of meters in X seconds at this constant rate. So that's why we multiply by time.delta time. Alright. So that is the check horizontal movement. I apologize if that was a bit long, but essentially what we're doing is we are getting the values for the horizontal, vertical, then we are taking those values and multiplying them by the transform.right and transform.forward vectors, which is going to give us a final resulting vector, our movement vector. That movement vector we then multiply by the run or walk speed, depending on whether or not the user is pressing the left shift, and that is going to be passed to the controller.move. And the controller.move is a function that's abstracted away that is just going to internally move the character in that position. So once you have this method created, go ahead and call the function here an update. You can see we have one more function that we're calling an update. So let me go ahead and make sure to zoom out so you can see everything, but go ahead and take a moment just to write out the method. Okay, so now let's talk about each of the components on this method. This one is maybe a little bit more complicated. So first we start out by determining whether or not the character is grounded. So remember at the very top you'll notice your private boolean is grounded. It's not set to anything, so that means it's going to default to a value of false. And then in this check vertical movement, in the first time it gets run through the update, it's going to update that value to true or false. And it's going to do that by invoking the physics system. The physics system has a specialized function in it called check sphere. The check sphere is going to take 3 parameters to this function. It's going to take a ground check position, the distance to the ground, and what you determine as ground. So to say that one more time, we are creating essentially a very small sphere at the bottom of our character. So here, inside of Unity, you can imagine that at this position of ground check, Unity is going to create an infinitesimally small sphere that's going to have a radius of 0.4. Why 0.4? Well, that's what we defined here in our ground distance. You can make that to be any value that you want. So we're saying, okay, I want you to create a sphere at this position. The sphere needs to be this big, and I want you to be able to interact with anything that has a layer of ground. And essentially what it's doing is saying if whatever is inside the sphere, so it's using the physics collision system, which is why I strongly recommend checking out the physics video either before or after this, just at some point. Um, it will use the sphere and the collision system to be able to determine whether or not an object with that layer is interacting with this sphere that it's created. So just know that if the ground sphere that we just created is on the plane with the layer of ground, it is colliding with it. When the player jumps into the air, because it's a parent-child relationship, that ground check is going to go with it. So of course it's not going to be touching the plane at that point, but when it finally gravity kicks in and it falls back down, it will eventually hit the ground, and then is grounded would result to a value of true. Okay, so continuing on here, the next check is if the vertical velocity dot y is less than 0, we are just simply defaulting it to a value of -2. So essentially I don't want you to be floating off into space is kind of what this check is for. And then after that we say, okay, if the character is grounded, so if is grounded is equal to true, we can just say is grounded by itself. That will automatically resolve the function and check if it is true. Then we do an ampersand, double ampersand to check an and condition. So both the beginning and second condition have to be true in order for this if statement to be executed. So it has to be grounded and the user has to be pressing space in order for this to function. If we are grounded and the user presses space, go ahead and set the vertical velocity of y. Now we're going to do a function here, a square root function, where we're going to take whatever the jump height is, which we set to a value of 3, multiply it by -2, and then multiply it by gravity. And then what we're going to be doing is, over time, this function is not going to be called because once the character jumps, they're going to be up into the air, and then gravity is going to be applying to them. So if they're going to start falling back down, they're not going to be able to press space because they're not technically grounded, and that's determined by this check sphere function here. We're going to be constantly adding the effect of gravity multiplied by that time dot delta time so that it's at a constant rate to the vertical velocity dot y. So again, I apologize if that's a lot of information, but taking a step back and abstracting a little bit more, what's happening is if the character's on the ground, if the user presses space, go ahead and basically boost them up by using the vertical velocity dot y function. Because the jump height we set to 3, we have a -2 just to give it a little bit more of a boost. And then we have gravity set to a value of -9.81, which is going to give it that positive value, multiplying two negatives together. And then over time, we are going to add gravity at a constant rate to the vertical velocity. So this could evaluate to a value of like 20 or something like that. So the character is going to shoot up 20 units. And then over time, the character has gravity applied, which is this function line here, and they will essentially float back down to the surface. Gravity function, -9.81 meters per second squared, so it is an acceleration function, so it will be going down at an accelerating rate. Finally, we go ahead and call that controller.move, just like we did up here. This one again is checking the X and Z values. This one is only moving the Y value, so they're kind of working in sync or harmony with each other, where we have WASD controlling the forward and backward left-right movement, and we have this vertical movement function controlling only what's happening on the Y-axis. Alright, so that is this script in a nutshell. If you want to see the whole thing, there it is. Again, if you have any questions about this specific script, of course, please do not hesitate to reach out by leaving a comment in the comments section or out to your instructor, as they will be able to help you a bit further. Now, we are about half done. I know this video is getting a little bit long, but I promise we are just about there. Next, I would like you to go ahead and child the main camera in your scene, which is currently sitting outside of it, to the player. It doesn't matter what order it's in. It could be in this order or that order. We just need to make sure that the main camera is childed to the player, and in this case, I would like to set the transform to 0.8 and 0. The Y value is just going to determine, well, how high is that camera actually. You could make the camera all the way up here, and then the player is going to be really tall, but we'll just leave it at a nice value of 0.8. Okay, so with the camera, we're going to have to create a new camera script to be able to rotate the camera as the user is moving either the arrow keys or the mouse. So you can see the second script already here. Go ahead and right click in the scripts folder, select create and C# script. And I called this one camera follow. You can see here at the bottom. Again, all one word, capital for the first letters of each word. Go ahead and open up that empty script inside of Visual Studio, and just like the last one, here is the entire script if you would like to copy it down all at once, but we are going to walk through each component of it now. Alright, so the camera follow script has less variables than the other one. Starting off, we have a public float, the fine point precision decimal number representing the mouse sensitivity. So this variable, we'll talk about it more in the actual calculation, is going to be used to determine essentially how fast do you want the camera to move when the user is moving the mouse. Then we have two variables. We have another float for the X rotation. Now the X rotation is going to be the up-down rotation. I'm going to talk about that in just a moment, so hold that thought. And then we have the private transform player body. So again, we already talked about what a transform is. This is referencing the parent game object, which is the player object here. The reason why, again, we'll talk about this, but is when we rotate the camera around like this, we want the player to be able to move in the direction that the camera is looking. And the only way we're going to be able to do that is when the camera is rotating, we need to rotate the player prefab Z direction. The Z direction is the forward direction. We need to match whatever the forward direction of the camera is to the Z direction of the player so that essentially they are going in the same direction. Okay, so now that you have these variables declared above your start function, let's go ahead and take a look at the start function. In the start function, we have three lines. The first two are essentially just hiding away the cursor. The first line basically makes the cursor invisible. The second line is going to lock the cursor. So the process of locking the cursor essentially makes it so that the user can't use their mouse while they're in the game outside of the game application. So it kind of locks the mouse into their application. Really helpful. That's completely up to you on whether or not you want this feature in your game. You can comment this line out by putting 2 slashes in front of it if you want the player to be able to use the mouse outside of Unity. Again, completely up to you. And we have that private transform player body reference here, and then we set that reference to the transform.parent. So you'll notice that this transform has an uppercase T, this transform does not. The reason why is because this transform is the transform actual class that's being used to store a reference to the player body themselves. We set the reference player body here in the start function by setting it equal to transform.parent. This transform is a special Unity notation that refers to the transform of the game object that this script is attached to. This script we attached, or go ahead and attach to the main camera, so click, hold, and drag onto the main camera. So the transform, when we say transform.parent here, it's referencing this transform and then it's getting the parent of it. The parent of it is going to be this player object. If we had a relationship like this with the camera follow on the ground check for some reason, the parent would be the main camera, but that's, of course, not what we're doing there. Okay, so going back to this script now, that is what the start function is doing. The update function is simply calling off to the check rotation function. Alright, so what is the check rotation? The most complicated and only method of this script. So it is a private, meaning it can't be accessed by other scripts, void method, it doesn't return anything, called check rotation. And let's dig into the meat and potatoes. So we have the yaw and pitch. So if you fly airplanes, this is familiar to you. If you don't, when we are yawing, we are going kind of like this. You can imagine my hand is an airplane. The airplane's going like this. The pitch of the airplane is how it's rotating like this, and the roll is how it's going from side to side. So when we are moving the mouse, we want to be able to control how it's going up and down, as well as how it's going left and right. You could also program the roll in there, and that'd be a pretty cool camera effect, definitely. But for the purpose of this, though, we're not going to. Okay, so we are going to declare two temporary variables in here. So these are local variables. Temporary local variables are synonymous in this case. They are only going to exist within the context of this function. Each time this function is called, they are going to be recreated and initialized to this value of 0. Then you can see we are going to set the values of the yaw and pitch. So here we are doing input.getAxis mouse x and y. Again, you can access the settings for that if you go to Edit, Project Settings, Input Manager. We saw and talked about the horizontal and vertical previously. A little bit further down the list is mouse X and mouse Y. And as you can imagine, it's getting the information from the mouse. When you move the mouse left and right, and when you move the mouse up and down, that's where that information is being stored into. That's about the extent of what you need to know for that line. So again, that's going to return values between -1 and 1, just representing how the mouse is moving per se. And then we take that value and we multiply it by the sensitivity. So we could be moving, I believe I set it to 100 inside of the main camera mouse sensitivity. So if I'm moving it to the left, I'm going to take 100, multiply it by the -1, and then I'm going to multiply it by the time, not delta time, just as a constant rate. Same thing for the pitch. We multiply it by the sensitivity and time.delta time. Now you'll notice this section of code here. This is a special, if you have this typed out already, great. If you don't, go ahead and type it out exactly as you see it here, paying particular attention to the syntax. This is the / and the star, and then we have the star and /. This is a multi-line comment, so it just allows us to comment out each line. Otherwise, we'd have to go through and do, okay, this is a comment, that would take forever. Let me go ahead and re-comment that. The reason why I have this here and commented out is because I'm going to talk about it after I show you the initial, it working with just the mouse. This is an alternative way to do that. So far your check rotation should just have these 4 lines. And if you type this out, this commented out. And let's move on to the bottom now. So this is one of the lines that confuses people the most, are these 2 lines. So I have a variable up here that I said I would talk about later, and I'm calling this the X rotation. This X rotation is going to reference the pitch of the camera. So what I say is the X rotation is equal to my desired pitch. If I take a look at the X rotation here again, what I'm doing is I'm clamping the values. So we have a specialized library of classes, one of them being the mathf. It has a clamp function, and you define an upper bound and a lower bound, and it basically says I need this value that I'm passing in to be within those values. So if it were like -100, it's going to be clamped to -90. If it was 180, it's going to be clamped to 75. The value that we want to clamp is the X rotation. Why is this important? So if we take a look here at the main camera, and specifically if we take a look at the X rotation here, go ahead and move the X rotation. What you'll be able to see is there we go, that's what I wanted. Sorry, I got a little confused there. So the main camera, to be able to see the preview of it, you have to click on the name of it. That's not intuitive, but that's okay. So with that name selected, what I wanted to show you was when you rotate the X right here, it's going to move the camera up and down just like this. So it's kind of like when you move your head up and down, the same principle. We are clamping the values between -90, which is going to be straight up, and then I believe the second value is 75, which if we rotate down to 75 is going to be about right there. Essentially, I just don't want the character to be able to go yeep and rotate all the way behind them like this and essentially turn their world upside down. If you wanted them to be able to do that, that would be perfectly fine. Just don't use these 2 lines. But we're just essentially clamping that pitch between 2 set of predefined values. Okay, so we've done a lot of work. We've got the mouse X and mouse Y input. Now we have to go ahead and set the rotation of the object. So this is a critical part here. Transform refers to the object that the script is attached to. This camera follow is on the main camera, so this transform is going to reference the main camera. What I'm saying here is I want the main camera's rotation. To reference the rotation, it's best to use the local rotation. And then this confusing statement here, I say the rotation of the main camera I want to be equal to quaternion.Euler, so a set of Euler angles. Quaternion, whenever you see this fancy word, immediately think of rotation values. And what we want to do is rotate it on the X for the pitch and then 0, 0 for the Y and Z. So to give you some perspective, the only thing that the mouse is controlling is the ability for the camera to go up and down like this. That's the only thing it's doing. But you're saying, but we got the values for the ability to look left and right. Why aren't we using those? Well, we definitely are. We're going to be utilizing the, the Y just like this. Let me reset my Z here. We're going to be utilizing the Y, but we're going to be giving this information from the Y to the player controller themselves. Why? Because we want the capsule object to rotate in sync with the camera. So let me go ahead and just reset all of this stuff and change that back to 0.8. Okay. So what we're saying is, the only thing I want you to do is rotate the camera up and down, and then I want you to reference the player body and rotate it, multiply it by the vector 3 dot up. Vector 3 dot up is going to be up, so you can imagine it's 0, 1, 0, and then by the desired yaw. So that yaw again is going to be like this. So essentially what we're saying is, I want you to take the rotation of the main camera, its yaw, and I want you to give it to the player. So when they give it to the player, that's going to allow the player capsule to be able to rotate on that Y, such that it's going to move in the direction of the camera. Okay, so I think we've done enough talking now. Let's go ahead and see this first-person controller in action. So again, we have our ground set up just like this. In case you missed anything, just double check all of your things here, but I believe we should be all set to go ahead and click play. And if you have no compilation errors, you'll be able to take your mouse and look around in the scene. You'll notice that as we rotate and we have the main camera selected in the hierarchy, you can see the rotation gets clamped to 75, it gets clamped to, well, 90.00001, so it's not exactly perfect. We have a little bit of a rounding error, but that's no problem at all. And then if we take a look, if you press escape, that's going to give me recontrol of my mouse. Click on the player object in the hierarchy, and then re-click in here. When I rotate the player, you can actually see, because we were doing the vector 3 dot up, multiplying it by the desired yaw. That desired yaw takes the left and right movement of the mouse, multiplies it by vector 3 dot up, which is the 0, 1, 0. So that is essentially going to say, okay, I want you to be 0 on X for the rotation, 0 on Z for the rotation, but whatever the mouse is rotating to, that's what I want you to set your value to. So we have the X and Z working together, and then you'll notice when you press WASD, those keys are also being interpreted for that as well. Alright, the very last thing that I wanted to talk about here is just a different way of doing this. So if you didn't want to use this way, I'm going to comment these out by putting 2 slashes in front of them. And then to uncomment this section, go ahead and delete the opening and closing multi-line comments. So now we just have this block of text. Here we're using the input.getKeyCodes, the arrow keys. And all this is doing is it's mimicking what the mouse is doing, essentially. The mouse is going to give you input between 1 and -1. We can see here that we have minus, equals, and plus to kind of control what that yaw and pitch should be. But essentially it's the same function as what's going on up here. The only difference is we're controlling it by the arrow keys now. So if we go back into Unity and Let me save, and it's going to recompile and refresh the Unity interface, and we press play. I can move around, but I am moving my mouse all over and it's not moving. But if I were to use the arrow keys, I can now rotate my first person controller using WASD and the arrow keys at the exact same time. So a little bit different of an experience, but I wanted to show both ways of doing it. Alright, so if you stuck with me through the end, thank you very much. I hope this video was very informational and giving you an overview of the different components that go into creating a first-person controller. There are, of course, other ways to create first-person controllers. This is just one flavor in the grand stew of different ways of doing it. That was a weird way to say it, but if you have any questions at all, please do not hesitate to reach out to us, leave a comment on the video, or contact your instructor for further help. Thank you very much.